Dear students, today we'll learn congruence of triangle. So, triangles, we know that when a segment coincides with another segment, then those segments are congruent. Similarly, when two angles coincide with each other, then two angles are also said to be congruent. Now let us consider these two triangles, triangle ABC and triangle PQR. Now these two triangles can be written in 6 different ways, putting one triangle over the other. So the correspondence, 6 correspondence, 1-to-1 correspondence can be 6 correspondence of these two triangles can be written in this manner. Triangle ABC, vertex of triangle ABC correspond to 1-to-1. This is the symbol of 1-to-1 correspondence to PQR, vertices of triangle. Second correspondence can be written as, we'll fix this vertex of triangle ABC and we'll change the vertices of triangle PQR. So P fix, just change this to RQ. Then third, fix this vertex of triangle ABC, take first Q and then PR. Fourth, vertex ABC 1-to-1 correspondence to Q fix R, change this RP. Fifth, ABC corresponds to, now take first R and then PQ, and last is ABC 1-to-1 corresponds to R, change this order, QP. These are the 6 ways, 6 correspondence of a triangle with another triangle. So in 6 different ways we can write the triangle. Out of the 6 correspondence between the vertex of the triangle, if there exists at least one out of the 6, if there exists at least one correspondence that in which one triangle covers each other exactly the other triangle. Like here, this two, let us consider this triangle ABC exactly overlap on triangle PQR. So here this vertex A corresponds to vertex P, vertex B corresponds to vertex Q, and vertex C corresponds to vertex R, and both these triangles overlap each other, exactly overlap each other with respect to their correspondence. Suppose this ABC 1-to-1 corresponds to PQR, then these triangles are congruent. These triangles are congruent and they are written in the form triangle ABC is congruent to, this is symbol of congruent to triangle PQR. Once two triangles are congruent, then all 6 elements of one triangle are congruent to corresponding 6 elements of another triangles, means 3 angles. Angle A is congruent to angle P, test of congruence of a triangle. Now first, if in 1-to-1 correspondence, if two angles of triangle ABC and included side, two angles and included side of triangle ABC is congruent to two angles and included side of triangle PQR, then triangle ABC is congruent to triangle PQR by angle side angle test. Angle side angle test of congruence. If two angles and included side of triangle ABC and two angles and included side of triangle PQR are congruent, then two triangles are congruent by angle side angle test. Second, in a correspondence, 1-to-1 correspondence, A goes to P, B goes to Q and C goes to R. If two sides and included angle here, two sides, side AB and side BC and angle B of triangle PQR is congruent to corresponding two sides and included angle of triangle PQR, then triangle ABC is congruent to triangle PQR by side angle side test. Now, third one, if for in a correspondence, if all three sides of triangle ABC are congruent to corresponding all three sides of triangle PQR. Here side AB is congruent to side PQ, BC is congruent to side QR and AC is congruent to side PR. Then triangle ABC is congruent to triangle PQR by side test. Now, to observe this diagram, both are right angle triangle and side opposite to right angle. This is 90 degree. Side opposite to right angle is called as hypotenuse. Here also it is hypo. Side opposite to angle Q is 90. So now, in a right angle triangle, for one 1-to-1 correspondence, here A corresponds to P, B corresponds to Q and C corresponds to R. So for in a correspondence, if hypotenuse of triangle ABC and its side AB is congruent to corresponding hypotenuse of triangle PQR, that is PR, and side PQ are congruent, then these two triangles are congruent by triangle ABC is congruent to triangle PQR by hypotenuse side test. They are congruent by hypotenuse side test.